All right, let's get started. This lesson number 17. It covers two things: the end of equilibrium, talking about equilibrium and free energy, and then acid bases, the very beginning of it. All right, so problem 17a, we're asked, we're given a reaction, we're given a delta G, and we're asked for K, the equilibrium constant. So we have these two equations that relate delta G and K. And they're just the same equation, just rearranged. So which one am I going to use? Notice we're given delta G here. We know R, and we know T, because it's 298K. So let's say I wanted to use this equation. I know this, I know this, I know this, and I want to know this. Well, what would I have to do? I'd have to rearrange it. I need to plug in. Then I'd have to take E to this to get rid of it. But if I use this equation, I know G, R, T. I can just plug them all in. Okay, so we're going to use this equation. All right, so K equals E to the negative 6.20 kilojoules per mole. Okay. Be careful about the signs and also watch out for the units. Divided by 8.314 joules per mole K times 298K. All right, notice this is in kilojoules, this is in joules. Not going to work. So let's just go 6.20 kilojoules is, for every 1 kilojoule, I have 1,000 joules. That's going to get me negative 6,200 joules. So I'm just going to plug that in there. All right. Always make sure units work out. Notice joules and joules will cancel out. Moles and moles will cancel out. K and K will cancel out. All right, so this will give me E to the negative. All right, we're back. I just had a slight hitch. All right, so I go ahead. I plug this all in. 6,200. Divided by 8.314, divided by 298. That's going to get me negative 2.502, right? Negative and negative, so this will be E to the 2.502. That's going to get me, on the calculator, on mine I do second, and then this E to the X right there. That's going to get me 12.2. All right, so my K is 12.2. What does a K of 12.2 mean? That means that I'm going to have a lot more products than reactants. So this is a reaction that's very far over to the right. Okay? Now let's go ahead and use this value for K, and let's figure out the second part of this. So we just figured out this is 12.2, and the second part of it asks, based on our K, what are the values for K plus, potassium plus, and Cl minus at equilibrium? Now remember what K is. K is going to be products over reactants. So that's going to be K plus times Cl minus over 1. Okay, I'm just going to get rid of it. All right, and this is going to equal to 12.2. All right, now there's one thing to remember, that K plus and Cl minus have to equal 12.2. But we don't know what values they are. We have two variables. Well, let's go ahead and let's do really quick an ICE table, right? We don't know how much we started with. Actually, we don't care about the KCl, I, C, E. We're told that we had no K plus and Cl minus initially. So that means Q is equal to 0. So that means it has to shift left or right. So that means plus X and plus X. And so X, right? What this means is that my K value is equal to X squared, right? Where X are these concentrations. So I can go ahead and I can now say that 12.2 equals x squared. And therefore, x equals the square root of 12.2, or some number, 3.5, or 3.49. We're talking about molarities, so this will be in mole. All right, so let's look at this on the screen. We start off by plugging in our delta G. Be very careful of units, right? We get our value for K, in this case 12.2. That means I have a lot more product. And now I can go ahead and use my knowledge of what K is to figure out my concentrations, okay? Notice that I'm going to get very high concentrations in my K plus and Cl minus. If you look back in the regular lecture, we looked at AgCl. And AgCl, when we put it into water, we got very small concentrations, like 10 to the negative fifth, right? Here we get very big concentrations. All right, so now let's move on to 17.5, or sorry, 17-B. 17-B is about acids and bases. Acids donate H+, bases gain H+. So when I have HSO4 minus plus OH minus going to form SO4 2 minus plus H2O. Okay? So I look at this and I say, what's happening to my HSO4 minus? It's losing an H+. So if it loses an H+, that makes it an acid. And that acid is going to go ahead and it's going to form a conjugate base. Acids produce conjugate base. Well, that means my OH minus, to get to H2O, it must gain H+. So that means this is a base. And this is my conjugate acid. Okay? Bases produce acids, acids produce bases. Okay? That's one example. Notice that OH minus is a base. OH minus will always be an base. All right, our next problem. We have Cn minus plus H2O going to form HCN plus OH minus. All right, so Cn minus, what's it doing? To go from Cn minus to HCN, it has to gain a H+. That makes it a base. And this must be conjugate acid. H2O loses an H+. So that makes it an acid. Okay? And this must be the conjugate base. I mentioned this in the example, but this would, or in the video, but this would be what we would call KB, right? This is base ionization. Okay, now let's do C. In C, we have HBr plus H2O going to form Br minus, or H3O plus Br minus. All right, my HBr goes to Br minus, so it loses H+. By the way, how do I know it goes to Br minus? Because I can't think of a way I can go from HBr to H3O plus. That just doesn't make sense. All right, so it loses H+. That means it's an acid. This makes sense because HBr is one of the acids we learned in 215. H2O, it actually gains a H+. That means it must be a base. This acid is going to produce a conjugate base, and this base is going to produce a conjugate acid. Okay. I mentioned this in the video, but notice how in this case, H2O is an acid. Here it's a base. Okay. H2O can act as an acid or a base, depending on the situation. Okay? All right, this is what we call base ionization, a base reacting with water. This is what we call acid ionization, an acid reacting with water. Okay, let's do the other two real quick. All right. When I do this on my in class, I can just use document camera and just get rid of the paper, but here it's a little tougher. All right, so we have if HF is an acid. So I'm told that HF is an acid. Okay? What is its conjugate base? All right, so HF, we're told that it's an acid. Okay? When we're told that, we need to remember what acids do. Acids donate or lose an H+. Okay? Acids always do that, right? So HF is going to lose an H+. So if HF loses an H+, it's going to become F-. This is my acid. This is my conjugate base. Okay? A conjugate base will always be after losing an H+. E, we're told that NO3-, all right? NO3- is a base what's the conjugate acid? All right, so in this case, we know NO3-, if it's a base, that means it gains an H+. Here it loses an H+, bases gain H+, so it's going to become HNO3. Right? This is my base. This is my conjugate acid. All right, so let's look at those on the screen. Remember, whenever you do these problems, you're always looking and you're saying, hey, what's happening to this? If it gains an H+, that makes it a base. If it loses an H+, that makes it an acid. All right, next time we'll get in a little bit more into the math involved in acids and bases. All right, bye-bye.